So picking back up, we're on Chapter 6, looking at slide 34 of the Chapter 6i.ppt. So I skipped several pages tracing the mouse program, and then they get to another UML diagram. And I think we've talked about UML, where UML is a description of the class in its most concise form, where a mouse is where we list the class name and then we list the data, the variables, and then on the block at the bottom we list the methods. If we look at this particular mouse class here, what they've done is they've declared all of their data private. They have an age, they have a weight, and they have a percent growth. They provided getters. You can get the age of the mouse, you can get the weight of the mouse, but you can't set it. You can't set the age, you can't set the weight. The only time those things can be set is when they are created. They default to 0, and then each time you call grow, those increase. And so this is pretty similar to the examples that we've given already. They're just showing another class called mouse2driver, and they describe that in the main class, the main method of the driver class, the client code, your main class, then they use a scanner to read in some information. They create a mouse2 object, and then they use that stuff. I'm not going to focus too much on that, but I do, of course, want you to have the idea of data encapsulation, which is data hiding, making your data private and your methods public. And the reason to do that is to prevent your program from messing with that data in ways that it shouldn't be able to setting it to invalid values. If age was public, you might be able to call Mickey.age equals -10, and suddenly that mouse is -10 years old. By not even allowing access to it, by making it private and not putting a setter, then you know that that's not going to happen. The age is always going to be positive, or at least, a number greater than or equal to 0. Same for weight. If weight was public, then the client code could call mouse.weight and set it equal to 1,000,000, and you know your mouse isn't supposed to weigh 1,000,000 grams. So again, you can validate, you can make sure that all the information in this object is as good as it possibly can be. So if you do provide setters, you can do some sanity checking. If you are allowing them to set the weight of the mouse, then you just make sure that they can't enter a weight less than 0 or equal to 0 or greater than, a kilogram or whatever the maximum size of a mouse is. That'd be a pretty heavy mouse, 2.2 pounds. So variables. A local variable, that's what we've been using all along. It's one that's declared inside a method, or inside of an if statement inside the method, or inside a while loop. It's defined inside a pair of braces inside a method. It's different from an instance variable, which is declared up at the top of the class outside of all the methods. So a local variable is called local because it can be used only inside of the method in which it is declared, only within the curly braces in which it is declared. It's completely local to the method. You can't view it from another method. If you want that data to be accessible to another method, you either have to pass it in as a parameter, or you have to revise your logic so that it is now an instance variable. So if you need to get data out of a method, you can use a return statement. That lets you pull data out of that method. It allows the method to pass the data back so that it can be used by the client code. Because just like you can't access a local variable from within another method unless it's being passed in as a parameter, you can't get that data back out unless you have a return statement. Void means that it doesn't return any data whatsoever. You Python programmers have seen something slightly different. I'm not going to even mention it, but here it means absolutely no data is passed back. You don't even need a return statement. If you put a return statement there, then NetBeans is going to warn you that it was unnecessary. So for methods that have a void return type, it's legal to have the empty return statement. It's in fact a syntax error if you try to return something and it was declared as void. That would be an error. So the empty return statement does what you'd expect. It terminates that current method, causes control to go back to the calling module at the point that follows a method call. You know, you could declare a method, void x, you know, and all it does is return like that. And then you could have, you know, down in your main code, you could call x, excuse the fact that this is capitalizing things all over the place. You know, you could do like that. Well, it's going to come up here. It's going to run this method. Control gets passed up to that method. It does everything inside the braces, which is just a return statement. Return sends it back down in here, and since there's no return value, there's no return value that you could store here. If you tried to do a is equal to x, it'll give you an error because it's declared as type void. So just flat out doesn't have anything in which to return. So control is given back to the function, and then it would just execute the next line underneath the function, the method call. There I go, messing up my terms, method and function. So here we go. A grow method within our mouse class. We're going to say that if once a mouse reaches 100 days old, it never gets any fatter. Apparently that's the maximum size. It's a fully grown adult at that point. So inside their grow method for the mouse class, they check its age. If the age is greater than 100, they just return. They just bail out of the function completely. Kind of like our break statement inside of loops. It doesn't do any of the rest of this stuff because it returned out of it. So code that uses an empty return statement can always be replaced by code that does not use the empty return statement. But you'd have to rewrite it. For example, here's a return less version of the previous grow method. Here you go. If the end of the age is greater than 100, you set it equal to 100, and then you do something there. Whatever. If you want to put a return statement in there, go ahead, but if you wind up littering your methods with return statements, it's harder to understand them. It's harder to understand your method, to read it and figure out what it's doing. So generally, the hardcore rule is every method should only have one return statement. And that's kind of true, but this is a very common programming paradigm. You write a method here, you know, void do something, whatever, and it starts testing error conditions, you know. If cannot open file, return. Yeah. If file contains no data, return. And you'd do something else too, right? You'd print out error messages, or you know, you'd do something. And then you'd have a bunch of code that processes the file, like that. There's nothing wrong with doing it that way, with putting a bunch of error handling at the beginning of the function, and then actually processing your data. In which case you could wind up with multiple return statements in it. But if you just mix them in there like this, especially if you have more than one of those, you know, another one kind of tucked, you know, 30 lines further down it's getting harder to read. Reading the code and being able to understand it is pretty important, because when you come back to it 5 years later, you're not going to be able to understand what you did if it's not clear. Software engineering observation. Real-world programmers are often asked to maintain, to fix and improve other people's codes. In doing that, they often find themselves having to examine the loops, and even more specifically, the loop termination methods. Loop termination conditions. It's important to note that loop termination conditions are clear. They need to be clear. Normally you put them in a while loop header, or a for loop header, or the do loop closing. But if you start sticking return statements inside a loop, that's a new loop termination condition. When we've done our while true, if value equals -1 break, you could also do while value is equal to -1, then return, that kind of thing. Then that's a new way to terminate that loop. It can be more complex to read. In the interest of maintainability, you should use restraint when considering the use of a return statement inside of a loop. Based on context, if inserting a return statement improves the clarity of the program, not just makes it easier to program, but improves the clarity of it, feel free to do so. But if it makes the code easier, but it makes the code harder to read, then figure out how to do it in another way. Local variable default values. Local variables don't get default values that you can use. They call it garbage here. It just is not initialized. So if you have your code here, void do something, and you do int a, right? Later on, you can't say a++. Why? Because a doesn't have a value to begin with. That's because this is a local variable. Local variables are not initialized with valid values. Textbook calls it garbage. However, instance variables are. So if this was a class, my class, and we had some instance variables, private int y, like that, that is initialized to a valid value, 0. So to sum up, down near the bottom, if we were to write some notes for what we've talked about so far, make your code easy to read. Limit the use of return statements in loops, and I would say in the middle of a method to be in general. Prof's rule of thumb, return statements go at the beginning for error handling, or at the end, but not in the middle. But if you think it makes the code more clear to go ahead and put the return statements in the middle, go ahead. What's the next thing to talk about? Default variables. Local variables do not get default values that are valid. So this is an error. Int foo, just like I showed you, and then you make a variable and then you try to do something with it, x plus equals 1, something like that. That's going to be an error. Has not been initialized. But instance members and class members, those are initialized properly to 0. But instance variables and class variables are initialized to 0 or to false if it's a Boolean variable, or null if it's a reference type, meaning a class variable. That's the wrong term. Like if it's a string but you don't assign it a value, or if you're putting dogs in a car object, and each dog points is another variable of type dog. That's called a reference variable. Anytime you create a variable that has a class name, like animal A1, A1 is a reference variable because it's going to refer to an animal. String S2, S2 is a reference variable. Scanner SC, SC is a scanner variable, a reference variable. A1, S2, SC are all reference variables because they can contain a reference to an object. Animal A1 without a declaration like that, if it's part of a class, is null. And then if you do A1 is equal to new animal and you create one, now it refers to that object. Like that. So this new keyword invokes what's known as the constructor. The constructor is a method inside the animal class. If you do not provide your own constructor as one of the methods inside the animal class, one is provided for you by the Java compiler. You just don't see it. That's called the default constructor. Argument passing. What is the output for the following mouse3 driver and mouse3 classes? I don't know. We have a mouse3 class that allows us to call the grow method and to specify the number of days it's going to grow. So in the client code, we create a mouse, and then we're going to grow it 365 days in a row. So when we print it out, it's going to print out how many days old it is. Okay, well that's easy. We didn't change it, so it's obviously going to print out 365. We are passing in that value of 365 in there, and nothing can change it. There's no way that method could change that value of 365, even if it looks like it could. And this is pretty important, so I would like everybody to eyeball this if you're working on homework or something like that. If you do this, void change me, and you allow the program to pass in an argument like that into a parameter, and then you do this, x1 is equal to 1000, and then down here in main or something, you call that like this, int a is equal to 3, change me a, and then you print it out like that. What's it going to print out? I'm going to make it look sneakier by calling this x1. I'm going to make it look like it actually changes the value, but it does not. So here we have x1. It's got the value 3 in it. We call the change me method. This is an argument. It gets passed in to fill in that parameter. So x1 is now equal to 3 because that was the value of the argument. And then we change x1 here equal to 1000. So when we get back down here, is it going to print 3 or is it going to print 1000? It's going to print 3. It's a trick question, but not really a trick question. The reason why is that unlike some languages, Java does not do pass by reference. This variable is not this variable. Even though they have the same name, this variable is a copy of the data inside this variable. So it's like once you're in here, you just have a photocopy of the data, and it doesn't matter whether you crumple it up or paint it orange or whatever. Your original page is just the same. So Java is pass by value, pass by copy. So the parameter is a copy of this value. So when we go in here and change x1 to 1000, we're just changing the value of a copy, and the original is still 3. Now, that becomes more obvious if you give it a different name, right? That's what made it kind of a trick question, but not really. Once you get the concept down, you just need to know that when you pass in a variable like that, this parameter gets a copy of it. There's another comment I can make about that, but I don't want to throw in two competing ideas at the same time. When you take C++ or C#, you're going to see other ways of passing data in where you can change that value. What if you wanted to get that x1 back out of it? You'd have to put a return statement. Somehow, yeah, let's do that. If you did this, return x1. If it's going to return a value, we have to change its data type. What would we change its data type to? Yeah, it's an int because x1's an int. So down here we could do this. A is equal to change me. So we pass in a 3, it multiplies it, it sets it equal to 1000, we return it. This is returning 1000, which gets copied back into A, so when we print it out, it absolutely is 1000. But if we're not doing that, if we're not catching that value being returned, then it's still equal to 3 by the time we get here. I'm going to undo those changes. I just ask you to take me on faith on that rather than code it up in NetBeans. So why? Java is pass by value, pass by copy. So x1 is just a copy of the value of the A variable. It is not the A variable itself. Therefore, changes to x1 do not modify the value of the A variable. So Java uses pass by value. Pass by value means that the Java virtual machine passes a copy of the argument's value, not the argument itself, not a reference to itself. Thus, if the parameter's value changes within the method, the argument in the calling module is unaffected. Now that does make sense, because what if we went back here and instead of passing in, a variable, what if we passed in like a 9? Is this going to magically change a 9 to 1,000? The next time we print out a 9, it's going to be equal to 1,000? No, it's not. X1 is just a copy of this. So X1 has the value 9 in it, and we can change it to something else, but it doesn't change that. That's probably repeated that often enough. So that an argument and its associated parameter don't have to use the same name. I've had people, kind of challenge me on that because they didn't understand it. How could you use A here when you called it X1 here? It's because this is just being copied into that. You could call this anything you wanted to. That could be called, stored in a variable called Fred if you wanted to. Fred is equal to 3. Change me Fred. Print out Fred. There's no connection between the names of that and that. If they happen to match, great. If not, well, fine. Just like if you were passing in a literal, just because that said 9,000, that doesn't mean that. That doesn't make any sense at all. So specialized methods. Accessor methods, which I tend to call getters, but I want you to know the Latin term for it, accessor. A getter gets the value of it. Our mouse class had an accessor for the age variable so that we could get the age out of it. You call get age, all it does is return this .age. And I know that we demonstrated that a couple of times. Then the mutator. The mutator sets the value of the instance variable, like % growth rate. So just to hammer that in one more time, and we're on the last slide, so I don't mind drilling us one more time. We're going to create a class that has a couple of instance variables, and we're going to put in getters and setters, and we're not going to use that refactor encapsulate option that NetBeans gives us. Trying to think of a geometrical shape we haven't used yet. What is the volume of a pyramid? Google that up. Or a cylinder. I'm pretty sure we haven't done a cylinder. Alright, there we go. It's pi times the radius squared times the height. It's the volume of it. Okay. So a cylinder has 2 bits of information. Let's not be so hasty in getting away. It's got a height and it's got a radius. We don't need something that holds the value of pi, right? It's a constant. So we're going to need to create a class that has both a height and a radius. So go ahead and crank up NetBeans, create a project, and not in main, but in the same project as main, I'm going to remove the package statement so that everything goes into the default package. So I delete the package line. That creates a little error here. Create move class to correct folder. I do that. Please delete that default comment up at the top to change this license header. When I open the code, I don't need to know that we can change the license header. You can always put your name and a description of the program. So this is going to be client code for a cylinder class. That's enough about it, right? You could put the class if you wanted to be really awesome, CIT1613, whatever the date. Let's go to projects, find our current project, which is 26. Our main is right here, Java application 26.java. We could even delete this package because it doesn't have anything in it anymore. So I'm going to right click on it and choose delete. Just gets rid of that package declaration. Because now, since we deleted the word package, we don't have any package sub-packages in our application, no subdirectories. All right, I'm going to right-click on that, do new Java class cylinder, cylinder. It creates our class. Delete that top thing about the license. All right, what were the 2 bits of information we said we need to know about a cylinder? We mentioned 2 of them. To look at that formula.
Radius and height.
Yeah, we need the radius and the height, and we may as well make them doubles. Double radius, double height. Do we feel like giving them default values? If we do not, they will default to 0. I guess that's good enough. But we're going to make them private. Since they are private, we have to decide whether we're going to add setters for them. Do we want the client code to be able to change the height and the radius of the cylinder? And yeah, of course we do, because otherwise, you know, it's just going to be a cylinder with no volume at all, you know, pinpoint, no space. So let's provide setters, also known as mutators. So, but they need to be public so that the client code can access them. Public set radius, and it needs to accept a variable, a parameter, and I typed int, but that's not right because I want it to accept doubles as well. So double radius, this dot radius equals radius. Now does this, I skipped something. I missed a return type. Does set need to return anything? No, we're setting a value. We're not getting any value, so I need to make that void. Public void set radius. Does this have to equal the instance variable name? No, but it's a good idea, just so that when you're reading the code it makes sense. If you want to call that R, you could. If you thought that made the code easier to read, but I'm always going to call it the same thing. I tend to get lost if I don't do that. We also need a setter for height. So go ahead and add a setter for the height variable. It's going to look very similar, except it's not going to be this dot radius is equal to radius. It's going to be this dot height is equal to height. I'll type it in a minute. Let y'all type it in first. Once you add your setter for height, go ahead and build it. We're not going to run it. There's nothing to run. But just make sure that we don't have any syntax errors. Compile early, compile often. All right, I'm going to add my setter for the height. Public void set height, double height, in parentheses. This dot height is equal to the value that was passed in as a parameter. So that's a mutator, which is a setter. We also need getters. We want get radius and get height. Put them up above, why not? They're known as accessors, parentheses getters. You're not going to read the term getter in the book. They do need to return a value, right? Because otherwise, why are we calling in getter if we're not going to return a value? And they do need to be public so that the client code can find out the radius if it needed to. Public, double, get radius. But it doesn't take any parameters. Why? Because you're getting a value. You're not setting it. It's like if you ask somebody's name, you're not going to tell them their name right as you're asking them. Yo, what's your name? Bob. I guess my name's Bob. No, you don't do that. Okay, so, and we're going to return this dot radius. Do the same thing for height. Make a get height method. So, public, double. Why did I make it a double? I just wanted it to match the data type there. get height, parentheses in parentheses, curly brace, return this dot height, this object's height value. Alright, we have a class. It contains data. It's not going to do anything with it, but we may as well go back to our client code in the main method and at least make sure that everything compiles. So I'm going to go down to here where it says to do code application inside my main method. Make a cylinder. Cylinder C1 is equal to new cylinder, parentheses in parentheses, and the C1 dot set height to 10. C1 dot set radius, parentheses 5. Now I'm going to build it with the hammer and broom. Make sure I don't get any errors. I'd like to see my output window. Not seeing that. Okay. Build successful. Very good. Now here's what I want to be able to do. I want to be able to do this. Double volume is equal to C1.getVolume. I don't have a getVolume method yet. So it's going to underline that as an error. Does getVolume need to be public or private? It has to be public because otherwise we wouldn't be able to call it from the client code. So I'm going to go back to the cylinder class and add a getVolume method. I'm going to add it to the top again. Don't know why I'm doing it this way. But so public double getVolume. It doesn't take any arguments. And we had a formula for it. Let me go refresh my mind. Pi r squared h. Okay. So double volume equals math dot pi times r squared times h times math dot POW, the radius, comma 2, times the height. And then we have to return that. Why? Because we have a return type here, so we need to fill that in with a return statement in the code. Return the volume. Could you have done this all in one line? Could you just say return math.pi times math.pow times height? Yeah, you could. Could you have added the this keyword in front of radius and height? Yeah, you could. Normally I would, but it would have made it kind of squirrel off the edge. The only time you have to use the this keyword is when you're differentiating. I'm going to scroll down here and show you. Here we have a parameter named radius. We also have an instance variable named radius. And if I did this dot, if I took the this dot out of there, then it just says radius equals radius. That's kind of dumb. It doesn't. It just assumes that the word radius applies to the parameter. It doesn't change the instance variable at all. So if there's any chance for confusion, you always use the this dot. I tend to use it everywhere. So I'm going to go back and modify that code to use the this keyword. Now that I've typed it, I'm going to go back to volume, and I'm going to say math.pi times math.pow this.radius. Did I have to make the change? No, it would have worked fine. Times this dot height. I just believe that to be more correct myself. It would have worked fine without it. All right, I'm going to go back up to the Java application. Well, I'm going to save this. Hammer and broom to build it, make sure I haven't introduced any errors. Go back to Java application, and I ought to be able to print this out. System.out.println C1's height equals end quote plus C1.getHeight. Parentheses in parentheses, another end parentheses, and a semicolon. I'm going to do the same thing for the radius. System.out.println C1's radius equals end quote plus C1 dot get radius, parentheses in parentheses, another parent in a semicolon. Now let's print out its volume, which we've already calculated and stored up here. System.out.println C1, and I don't know why I made C1 capitalized when the name of the variable is actually lowercase, but whatever. C1 space volume is equal to, end quote, plus volume, end parentheses, like that. And there we go. It's got a height of 10, it's got a radius of 5, it's got a volume of 785 dot, yeah. Did we need that many digits of accuracy? Not really. I'm going to change this to a printf so that we can limit its accuracy. This third one is the one I'm going to change. So instead of print line, I'm going to make it printf. It's going to be 3 changes. As a matter of fact, I'm just going to delete that line with some comments and replace it with a good one. System.out.printf C1 volume equals %.2f, meaning this is our placeholder, percent sign is a placeholder. Dot 2 means I want 2 places after the decimal point. F means it's a floating point number coming up. And then I want a \n after it so that it'll go to the next line, because printf does not automatically go to the next line, unlike println. Then after that quote, I need a comma, and I need to pass volume in. Notice that we used a comma rather than a plus sign there. That's because printf wants all the variables that it's printing out separated by commas so that they can fill in the placeholder, because they're arguments. Whereas a print line or a print statement builds a string by using plus signs to concatenate the entire thing into a string before it prints it. Alright, now when I run it, it's going to be prettier, I hope. Hammer and broom, green arrow. Alright, there's the volume. It would be useless frippery to go and make it accept input, but making another one would be a good idea. However, I don't feel like doing all of that stuff again, right? I'd rather make a method that did all that printing so that it's easy to call, so I don't have to copy and paste 3 print statements over and over. I think I'm just going to leave this exercise as is. Print it out for... Who needs a copy of it? Anybody need a copy? No. All right. Of the code that I've typed. You came in late, right? So you want it. Okay. They're not applicable to cylinders in particular, but I just want you to do some of this stuff. Let's, I'm going to put a description of the changes I want you to make down here at the bottom. Add these methods to the cylinder class. Add one that's a void. Here, I'll type it like this. Set radius height that accepts 2 doubles and sets the values of radius and height to those parameters. Return type void, because it doesn't need to do anything. And now we're just going to do some silly ones. Write a method, add a method to the cylinder class called Inflate. That accepts no parameters and doubles the radius multiplies the radius by 2. Radius star equals 2. And again, this one doesn't need to be anything, so its return type is void. All right, work on that for a couple of minutes. Then of course I'll show you how to do that. All right, so I'm going to do set RH now. Return type void. I tend to make all my methods public, data private, methods public. So public void set RH. It accepts 2 doubles. I didn't specify the names, but since it's setting the radius and the height, I think those would be perfectly good variable names. Double radius, comma, double height. Inside the method, this dot radius is equal to radius. It's kind of a double setter, double mutator. This dot radius equals radius. I'm getting some kind of errors. Well, that's because I put it outside of the class. How did I wind up putting it outside the class? I put it after the final brace. I want these methods to be part of the class, so I need to make sure they're not after the final brace. So I'm going to have to move that brace down to underneath all this stuff. So I should tab this stuff over too. Alright, now it's part of the class again. To prevent that kind of shenanigans, I usually put a comment on the very last brace that says end class. Alrighty, so this dot radius is equal to radius, this dot height is equal to height. Very good. I'm sure that that's adequate. Now how about inflate? Accepts no parameters, returns void, it's going to be public, and multiplies the radius by 2 using star equal 2. Alrighty. So public void inflate. No parameters. This times radius star equal 2. Now I actually do want to test these out. So I am going to go back to the main method, create a new cylinder, and play with it. So back to the main method, I'm going to make a new cylinder. Cylinder C2 equals new cylinder. C2.setRH. It's going to be a 5x5 cylinder. I'm going to get the volume out. Double V2 for volume 2 is equal to C2.getVolume. Now I'm going to inflate it. C2.inflate. Double.V3 is equal to C2.getVolume. I'm not liking that V2 and V3 business because it makes it look, alright. I'm going to change those names. It's not going to be V2, it's going to be V before, like before inflation, and V3 is going to be V after inflation. Now I'm just going to print those two things out. Systemout.printf before colon %.2f, couple spaces, or just slash in there, that'll work, comma, V before, semicolon. Then I'm going to do the same thing for the after. System.out.printf after colon %.2f \n end quote, comma, V after is our argument. Alright, going to run it. Hammer and broom to build. Green arrow to run. All right, so apparently doubling the radius of it makes the volume much more. And that's reasonable, right? Because you're squaring the radius. So, you know, the square of 1 is 1, but the square of 2 is 4. So by doubling the radius, you've quadrupled the value, and so on. That's not strictly true in this ratio, but same kind of idea. Maybe it is. What's 392? What's 1570 divided by 392? It is doubled, isn't it? I'm not sure of that. Anyways, so just like a circle, if you double the radius of a circle, it increases the area more than merely doubling it. Last thing I want you to do to your cylinder class is to hit Google, look up the formula for the surface area. And then implement a get area method that returns a double, which is the surface area of the cylinder. So go ahead and add that. If you need a model, scroll back up, find the get volume. And it's going to look similar, but it's going to have a different equation, right? Do this one. Get area. I don't know the formula yet, but I'm going to go ahead and plug in the structure for it. Public, double, get area. Does it take any parameters? No, it doesn't need to. It's calculating something. Now, one common mistake that people do is they think, okay, if I'm going to be getting the volume, I need to add a volume instance variable. And then get area could, just return that, like get height does. No, if it's supposed to be calculated, don't try to store it in there. Get area is calculated. Why? Because the area might change based on whether the height gets changed or the radius gets changed. You don't want to try to store values like that. Those are intermediate values, temporary values. Those are values that get calculated on the fly. So you don't want to make them instance variables. Okay, so double area. Who looked up the formula for area? What is it? Area is equal to what? I'm sure it involves pi, but what is it?
2 times pi.
2 times which?
Times pi.
2 times mat.pi
Times radius.
times radius
Times height.
times height plus, okay, I'm going to go to the next line, plus
2 times pi
2 times mat.pi
times radius squared.
times radius squared. Okay. Or mat.pow radius to the power of 2. That looks like it could be simplified, but I'm not going to bother. And then return that area. All right, just to test it out, I'm going to go to the main method, get the surface area of it. Double SA, surface area. Ah, come on, don't be lazy, Jeff. Double area is equal to C2 dot get area, parentheses in parentheses, and I may as well print it out. System.out.printf, area equals %.2f \n, comma, area. Alrighty. I trust that's right. I could test it out by going to a web page that calculates the area. I'm sure Google will be happy to do it. Surface area of a cylinder. Let's type one in. That was a 5 by 5 cylinder, but I doubled the radius of it, so it's 10 by 5. 942. Is that what I got when I ran it? Yep. Okay. Good enough. I'm convinced. Alright, lastly I want to make a UML for it. So pop open Word. It'd actually be easier in Notepad, except in, yeah, let's do it in Notepad. Go to your start box and type in Notepad or your other favorite text editor. And if you've already done it in Word, I don't care. That's great. You don't have to redo it. So I'm just going to draw a line using dashes. And what was the name of the class? Cylinder. Now I'm going to draw another line of dashes, and I'm going to list all the instance members. What were they? We only had 2. What were our variables? Height and radius, and they are private, so I'm going to put dash in front of them. And what types were they? Okay, so we had a height and we had a radius, and they were both doubles. Now I'm going to put one more line of dashes. Whoops. I guess that looks even better when I use underscore, but and I had several methods. There was set height, which took a variable called height, which was a double, and it was a void. Set width was very similar. These are public, so I'm preceding them with plus signs. Set width, the parameter name was width. It was a double. The entire method returned a void. Have I goofed? What did I do wrong? I did. I'm sorry, pardon.
We didn't use width as radius.
Yeah, you're right. Where did I get width? Alrighty, set radius. I was thinking in terms of rectangles. Thanks. Okay. Didn't use width. Very good. And we had one called set RH. So plus sign set RH, height colon double, or in the order in which you declare them. I don't remember which way I declared them. Radius colon double, comma, height colon double, and it returned a void. Then we had some getters. There are programs that will generate UMLs automatically from your code, which is kind of nice, right? Okay, so our getter, get height, didn't accept any parameters, and it returned a double. So get height, parentheses, in parentheses, colon, double. Radius was the same way. Get radius, parentheses, in parentheses, colon, double. And then we had a get volume and a get area. I think those were our last 2 methods. Oh, we also had inflate, and I guess we'll do inflate. So we had a method called inflate, didn't take any parameters, didn't return anything. Then get area, or get volume first. Get volume, did it take any parameters? Nah, but it did return a double. Same for get area. And then a series of lines to indicate the end of it. That's our UML for the class. Alright, so my last homework ought to be to give you a class and to ask you to write the UML for it. I think I'm just going to trust that this was enough. Alright, that's a good place to stop. Let's make a Dropbox for our work. So if you refresh your Dropbox, you'll see a Dropbox for the cylinder class, the code, and the UML. Please give me both of those. Any questions? Nope, all good? Alright.